Norton's theorem says that a part of circuit can be replaced by a current source and a parallel resistance. That means if we look at this example circuit, this whole part can be replaced by a current source and a parallel resistance. And then if we want to analyze the response in this resistance RL, that means the response means the current or current through or voltage across, we can apply Norton's theorem because this whole circuit will be simpler, so we can just do that and then we can find out the current. So this will be Norton current and this will be Norton resistance. The question is how to find the values. So in order to find Norton current, what is done is this resistance is removed here and replaced by a short circuit. So it's a short, and that short circuit current is calculated from this entire arrangement. So for this entire arrangement, what is the short circuit current here? That is calculated. So for this particular circuit, what will happen is we can see there are two sources here. One is the voltage source and there is the current source. So we can apply principle of superposition in this case. So but before doing that, if we notice something, this short circuit is actually shorting out these two resistances. So basically this circuit is becoming something like this. So if we erase this part, it is actually these two are being shorted out. So basically I short circuit is nothing but just I1 for this particular arrangement because it's very simple. So yeah, but otherwise if there was other resistances or whatever other arrangement, then we have to apply principle of superposition or any other method to find the short circuit current. Now how to find the Norton resistance? That is found by, so I will again apply the two resistances that were there. So this R5 or RL is removed now, and the resistance is equivalent resistance is calculated here, and that is the Rn. So but before that, all the sources inside are made inactive. So the current sources are made open, this one is open, and the voltage source is short circuit. So both of them are inactive. The voltage source is short circuit and the current source is open circuit. So now we will try to find the equivalent resistance R3, R4 looking from here like that. So we can see there is an open circuit here, so the current cannot flow this way. So equivalent resistance is just these two because these things don't apply anymore. Just R3 parallel R4 will be the Norton resistance. So once we find them, and the current here, the short circuit current was going downwards, so this will be the direction of current because the current will be in such a way so that because this short circuit was going this way, so in order to have that, the current has to go upwards in this source. So that's why this is the direction of the current, and this is the resistance here, and then we can just solve to find the whatever current or resistance here. So L will be IN over RL plus RN times Rn, just by using current divider rule. So again with the current direction, since the current was going downwards while short circuit because of this current source, this was this direction, so the short circuit current was going this way. In order to have that, this current source has to have an upward direction so that the current goes this way and goes downwards there. That's the reason. I will try doing an example later on.